Well, thank you for introducing the Asbetter Acids process to you. In this process, we are combining two environmental problems into one solution. One problem is the discharging of tons of waste acids, and the other problem is the landfilling of tons of asbestos cement. We combine these problems into one solution and one permanent solution. What we are doing in our process, we are mixing the asbestos fiber cement with the waste acidics. In this process, the waste acidics are neutralized by the cement of the roof plates, and at the same time, the asbestos fibers are destroyed. The process will reduce CO2 emissions because it's bringing a lot of products to the market, like gypsum, silica, and calcium chloride. So we produce in a factory of 60,000 tons of asbestos cement, more than 60,000 tons of raw materials to the market. We are currently engineering the first industrial plant, aiming to start production in 2024. And we are sure that our technology based on industrial acids can be implemented elsewhere at the industrial locations where they have a lot of waste acids. In the current situation, in fact, there's only one real possibility of asbestos elimination, and that's the landfilling. There are projects for biological degradation, especially interesting for contaminated soils. There are initiatives for thermal destruction, and there is a technical possibility for a CO2 reaction, but we found the best solution in the acid reaction by using waste acids from industry. The advantages of our process are, at first, it's a wet process, so this is safe because we are handling a dusty material. Secondly, it's a circular process by reusing and recovery of industrial waste acids and a lot of products coming out of our process. And we are realizing a 100% CO2 reduction by avoiding neutralization with lime and by regenerating new building materials. The drawbacks, well, there are, we think, two limits. Your processing will depend on the available volumes of suitable waste acids, and you have a processing location where you can possibly discharge the final flow of salted water. Here we are in the pilot plant where the materials are coming in and are safely stored, especially the waste acids coming from the Rotterdam industrial area. We are testing several types of waste acids. Going to the mechanical chemical destruction of the asbestos site, we are entering the containment area, and you will see that we are protecting our people with air-cooled suits. We are helping each other into the air-cooled suit, and then we are entering the containment for handling the mechanical steps and the chemical steps to destruct safely all the asbestos cement. Here the asbestos cement is put down into the shredder. In a pilot plant, we have a lot of work to do by hand. At industrial scale, this will be automatically done. Here we are processing the chemical steps. Communication with each other is very important. We are working on a system to make it more easy for them. Looking at the Netherlands, we know that we have to process a lot of asbestos cement roofs, a quantity of more than 800,000 tons, and the asbestos drinking water pipes remaining quantity of at least 600,000 tons, and extrapolated to Switzerland, that could mean the half for Switzerland. Well, looking at this process scheme, you see that our incoming materials are coming out of two industries. One from the construction and demolition industry is the asbestos cement coming, and the other one is the chemical processing industry where the waste acids are coming from. And we start with storage, and then we have a circular process, and I think this scheme emphasizes the circularity of the process, but everything starts with the pre-treatment and making the material as small as possible, and we do that with mechanical size reduction to start with. And after this, we start with the chemical process in several steps. And after every chemical step, there is a filtration step where the calcium chloride is coming from. And we are using the calcium chloride to make gypsum out of it, combining in the process the sulfuric acid waste acids. In the end, we produce gypsum, we produce silica, we produce calcium chloride, and bring this back to the market. And this picture at the left, you can see the cement matrix with also the asbestos fibers in it. It's our starting material before we start the chemical process. And in the right one, you can see the end material where all the fibers are gone, only the silica is left, and this is a very well and clean material to bring back to the cement and concrete markets. Here you see some gypsum produced in the laboratory. In this moment, we produce gypsum in our pilot plant, so we have huge volumes of it. In this overview, you can see what we are processing in our first industrial plant, coming in 60,000 tons of asbestos cement and 170,000 tons of waste acids, and going out as new raw materials, zero carbon, so to mention, is the magnesium hydroxide, the gypsum, the silica, and the calcium chloride. An important and maybe interesting government policy for Europe too is the current policy in the Netherlands on avoiding landfilling. There's actually a landfilling, but our government has written down the policy: if there's coming an affordable and safe solution to the markets to process hazardous waste materials, then the landfill ban will be activated, and the process maybe costs €205 a ton. There's also an interesting cooperation between government and the concrete and cement sector for the circular economy, recycling, reuse in construction waste. You see in 1985 it was at 50%. In 2010 the goal was 88%, and the future goal will be 100% circular economy in 2050. The government and the sector also agreed on reducing CO2 emissions, mentioning reducing by 30% and coming to use and reuse 100% high value of concrete materials again. And by this, you can promote the innovation and social capital. Well, after this short presentation, maybe someone of you is interested to come and visit us and to know more about this process. You're very welcome to visit us in the Netherlands. Please contact us at contact@asbetteracids.com.